What's up, everybody? I'm going to go over Physiology Lab, pretty much most of the respiration stuff. A lot of you by now should know what all this means here, but I'm just going to go over it quickly. Natalie came up with a really cool chart to remember these things. So you got tidal volume, inspiratory reserve volume, expiratory reserve volume, and residual volume, okay? And your inspiratory capacity is your tidal volume plus your inspiratory reserve volume. And then your, what is this one? Functional residual capacity is your expiratory volume plus your residual volume. And then you have your total lung capacity, is just your inspiratory capacity plus your functional residual capacity. And then your vital capacity is your tidal volume plus your inspiratory reserve volume plus your expiratory reserve volume. So if you can make this chart, you should be able to figure things out as long as you know what these things really mean. Just don't just memorize these letters in this chart. Really knows what everything means, but when you're taking a test, you can draw this out and it'll bring back all your understanding of all the concepts. All right, and then we're just going to go over briefly what happens when you're breathing. So you'll inhale, you'll expand your thoracic cavity. So my chest is coming out. This will decrease, you'll have a decrease in inner pleural pressure, which is the pleura. You might remember that from visceral last quarter. If not, you have your parietal and visceral pleura, and then it's the space in between those two layers of pleura. So you get a decrease in that intra-pleural pressure. You get a decrease in alveolar pressure as well. All right, with this decrease in alveolar pressure, you're going to have a higher atmospheric pressure and a lower alveolar pressure, and things always go from high to low. So the air is going to go into the alveoli and expand the alveoli. And then you're going to reach a point where you can't take it anymore, and you're going to relax or basically stop inhaling. And then elastic recoil of the alveoli is going to take place, and that's basically like stretching a balloon out. It's really elastic. And then the recoil is when you let go of that balloon and all the air just comes out because it snaps back. And then with the elastic recoil of alveoli, you get a release of the full expiratory volume. So all the air is going to come out just like that balloon. All right, and then something really bad that can happen is if you puncture the lung, your atmospheric pressure would equal your intrapleural pressure. And with equal pressures like this, you don't want equal pressure. You either want high versus low or low versus high. You don't want them the same, because if they're the same, you get lung collapse, and then you're screwed. So next we got the concept of anatomical dead space. It's all the air in your respiratory system except for the alveoli. Where we have the alveoli, that's where respiration's happening. That's where there's an exchange of gases, okay? So that's not dead space. That's where the actual activity is happening. But everywhere else, there's no exchange of gases, so it's just dead space. So whether it be your bronchioles, your bronchi, your trachea, whatever, that's all dead space. All right, so just keep that concept in mind. Next we have, we're comparing respiratory minute volume versus alveolar ventilation rate. These are both different ways of looking at rates of, I guess you could say, breathing to a certain extent. And they're both measured in liters per minute. So with the respiratory minute volume, you're going to take your tidal volume, and you're going to multiply it by your breaths per minute. So we have an example here. If your tidal volume is 500 mils, I'm going to multiply that by 12 breaths per minute, and you get 6,000 mils total of 6,000 mils, or 6 liters per minute for the respiratory minute volume. Now we have alveolar ventilation rate. The main difference here is with this, you're taking the alveoli into consideration. So you're going to take your tidal volume, and since you're just talking about what's going in and out of the alveoli, you can't count that anatomical dead space. All right? So it's tidal volume minus anatomical dead space, and then multiply that all by breaths per minute. And then we have a couple examples here. Say you start out, you have a tidal volume of 1,000 mils, and then your anatomical dead space is 150 mLs. okay? So you take 1,000 minus 150, you get 850 ml. So you got about an 85% efficiency rate. Now let's say if your tidal volume was lower, if it was 500 mils, your anatomical dead space is not going to change, okay? So it's 500 mils minus 150, you got 350 mils, all right? Now if you compare that to what your tidal volume is, you're only at 70%, okay? So therefore, if you increase your tidal volume, say from 500 mils to 1,000 mils, you're going to increase your efficiency, say from 70% to 85%. So keep that in mind. All right, and then next we're going to go to airway issues. There's two major things that we talked about. You can have an obstructed airway, or a constricted, aka restricted airway. We'll start with obstructed. With obstructive, some examples are asthma or emphysema. You're going to have issues with exhaling, okay? And basically you can take in a whole lot of air, but you just can't get it out. So it's like a one-way street. Air's going in and it's not coming out. All right, with that you're going to have decrease in expiratory airflow, which is expressed in liters per minute. You're going to have an increase in reserve volume now, or residual volume now. Because like I said, you're taking all that air in, you're getting all that extra air in, but none of it's coming out, okay? Or at least a decreased amount. So you're building up that residual volume, all right? And you're building up total lung capacity because you're constantly taking more air in, like I said. And your expiratory flow rate would also increase. Not sure about that one, but according to my notes, it increases. Constricted, aka restricted airway issue. One of those would be pleurisy. That's an example, and I forgot to write it up there, but with that you have an issue with expanding your lungs, okay? And that's going to result in a decreased expiratory airflow rate as well, okay? In this case, you're going to decrease your residual volume. You're not getting as much air in. You're not getting as much air out, okay? You're just almost cutting it off completely, or at least a lot. And you're going to decrease your lung capacity, and you're really going to decrease your expiratory flow rate for that one. All right, and then the last thing we have are, we're looking at bronchial constriction versus dilation. And with constriction, some things that can cause constriction would be your parasympathetics kicking in, all right? And parasympathetics, when you kick that in, you're involving acetylcholine. With your immune system, you're going to have a release of histamine, or leukotrienes. Leukotrienes, their effect tends to be stronger than histamine, so you're going to want to keep that in mind. And then some drugs that can counteract histamine would be antihistamine, and a drug that can counteract leukotrienes would be leukotriene receptor blockers. Okay. Now we move on to dilation. Some things that can affect dilation would be chiropractic care or caffeine. Okay. And with chiropractic care, you could also compare this to Sudafed if you want to look at it from a medical perspective, say. So with either chiropractic care or with Sudafed, you're going to increase the sympathetics, okay, and that's going to lead to a release of norepinephrine or epinephrine. All right, and with epinephrine, it's going to go to beta receptors, and you're going to have an increase in cyclic AMP. And another way you can get an increase in epinephrine, other than, say, your Sudafed up here, if you're going to go the drug route as well, is you can use an EpiPen. All right, maybe you've seen that in a movie where someone's taking that pen and jabbing it into the person's chest. That's an EpiPen. All right, and then we have caffeine. You can have caffeine or theophylline. They're going to have similar actions. But with theophylline, you're going to want to think of an inhaler. Like if you know someone that's asthmatic, they may have a theophylline inhaler that they take to cause bronchial dilation when they're having an asthmatic attack. All right, so either of these are phosphodiesterase inhibitors, and what those do is those can lead to, once again, an increase in cyclic AMP activity. And I believe that's it for this week. So, see you next week.